All right, guys, Module 11, Part 2, a binomial distribution. Again, I want to remind you that these notes are going to go along with the reading. You still must do the reading. The book has a lot more information than just the lecture notes. After you do the reading, make sure you're writing down any questions you have for me, and I can go over those in our 10 a.m. meetings. So I want to make sure you're getting as much information as you can. So we're still talking about distributions. So using the binomial distribution, you have to make sure that there's a couple of things happening, right? Whoops. Gosh, why can't I make straight lines, guys? Okay. So it has to meet the following 4 requirements to be a binomial distribution. Each trial of the experiment only has 2 possible mutually exclusive outcomes. We usually denote them as a success and a failure. There's a fixed number of trials, can't be an infinite number of trials. The experimental outcomes are independent of each other, okay? And I'll go through our example and make sure that you understand what each of these means as it relates to like a real problem. And the probability of observing a success remains the same from trial to trial, okay? So these 4 things. A success denotes the outcome we are interested in. It doesn't necessarily mean that it is a desirable outcome. Like one of the outcomes could be, I think this is one of the examples we get into, is that a bus is late. Well, that's not a desired outcome, but if the bus is late, that would be a success if that's what we're looking for. Okay. It gives an example here. A medical researcher wants to figure out the heart failure rate in elders who consume a lot of fat. And they would consider each case of heart failure a successful case, when of course, heart failure is not something you want for anyone, okay? So here's some of the notation. S, the outcome denoted as a success. F, the outcome denoted as a failure. The probability of a success is equal to P of S. Just so you know where I'm looking at, the probability of a success is equal to the probability of S is equal to the probability of observing a success. The probability of a failure, remember, since there are only 2 things, a success or a failure, then the failure must be the complement of the success. Remember, the complement is 1 minus what else is happening, and as always, the number of trials. Okay. All right, so here is the combination formula. Right? The formula can be read as N choose X. It tells you how many unique ways you can select X items from a larger set of N items. The exclamation point is called a factorial. What that means is if I have factorial of 4, that means I am taking 4, I'm multiplying it by 3, then by 2, then by 1, okay? If I have a factorial of 5, then it's going to be 5 times 4 times 3 times 2 times 1, okay? So let's go through our example. You have 3 pens, a blue, a black, and a red pen. So let's try to do this manual. How many ways can we choose 1 pen? 3 ways. You can choose 1 pen. You are either going to get blue, you are going to get black, or you are going to get red, okay? Underneath that, how many ways can you choose 2 pens at a time? Still 3 ways. You can either choose a black and a blue, a black and a red, or a blue and a red pen. So still 3 ways, even though you're doing 2 different things. Okay, checking the result with the formula. So this first one, how many ways can we choose 1 pen out of 3? So if you have a set of 3, we want to select 1. In this case, our N is 3. That's our number of pens, and we are selecting 1. So that's how we write 3C1 is equal to N factorial, which would be 3 times 2 times 1, divided by X factorial, but since X is just 1, we just put the 1 there. 1 times 1 is 1. Times N minus X, which would be 3 minus 1, okay? is equal to 6 over 2 is equal to 3. We checked our answer. There are, if we have a set of 3, we are trying to select one. There are 3 different ways to do it. Okay. Next, we have a set of 3. We want to select 2. So we write that as our n is still 3. This time we're selecting 2 at a time. So our numerator is still 3 factorial. 3 times 2 times 1, which is 6. In this case, our denominator, our x factorial, is 2 times 1. This is x factorial. And then we have n minus x. In this case is 3 minus 2. Okay, so 2 times 1 is 2. 3 minus 2 is 1. We still get a denominator of 2, even though we're doing different maths, is equal to 3. So we checked our second answer also. Now, if you have a bigger set, is there a way to do it on the calculator? Why, yes, there is a way to do it on the calculator. If we look at our example, if we have 12 pens, how many ways can you select a set of 3, right? So we have a set of 12 pens and we would like to select 3. So this is going to be 12C3. Right? Okay, and we just do this. We're gonna go to our math button. We're gonna right arrow to probability and then down arrow to NCR. So let's get our calculator. We're gonna click the math button, which is right under the green button. Right arrow to probability, down arrow to NCR. We have 12 pens. We'd like to select 3 at a time. 220 ways to do that. Whoops. Okay. All right, so the binomial probability distribution formula, good to know. We will be using the calculator for this, so don't get stressed out if you don't understand exactly what's happening in the formula. Do think about what these mean in your number of trials, just as before. X your number of successes, P the probability of success. Okay. Again, we're going to have a mean, a variance, a standard deviation, the same as before. We'll show you how to use it. This binomial distribution, we will really be using in our next, all of our last modules. So we need to get it now. We need to understand this now, how it's working. To find the mean or the expected value that we learned from the last video, you just take n times p. The variance, n times p times its complement of p, 1 minus p, and the standard deviation is the square root of the variance. Okay. So problem 1 says the RTD runs 15 trains through the Auraria campus stop from 8 a.m. to 9 a.m. Each train has a 35% chance of running late. Remember, that was one of the things we needed to have for our binomial distribution, is every outcome has the same probability of happening, 35% chance of they're either going to be on time or late. That's the binomial. They're on time or they're not on time. Okay. If you observe these trains as they arrive, answer each of these questions. Okay. So let me show you. Below is what we're going to type into our calculator, your TI. What I would like to show you before that, though, is this binomial calculator so we can actually see the distribution. So if you click on this link from your slides, okay, it brings up this cool binomial calculator so we can see what is actually happening, okay? So what we're doing is I'm going to go to this box that has n, and I'm going to change it to be 15. We're looking at 15 buses. And then right next to it, P is the probability that a bus is going to be late, which is 35. So I'm going to change this 0.5 to 0.35. And this is the cool part that we're looking at. This is the probability distribution. What's the word I'm looking for? My brain just farted. It's not a bar graph, it's a histogram. God, Rachel. It's a histogram of the probability distribution. On the right-hand side is a table that gives you all of the details. So the probability, if you're looking at, see how I'm moving my mouse over here? If you're looking at 0, the probability of 0 of these buses being late is 0.16, okay? The probability that one bus out of these 15 is late is approximately 1.26%. The probability that 2 of the buses are late is 4.8% approximately, okay? I think the first question on our here is, what is the chance that exactly 4 trains will arrive late? So I look at the table, and that says the probability is 0.1792, which is approximately 17.92%. And that's the answer we're looking for. But you can also find it on your TI, and this is important because you don't get to, if you're taking tests like the SAT, you don't get to have this cool online calculator, but you can use it for this class. I want to show you how to use it in your calculator. So let's double check and see if we get the same answer. Okay, so let's pull up our calculator here. The way we enter this in is you go to your distribution, which is second distribution, and we're going to arrow down to the PDF, binomial PDF, which is A. I'm going to hit enter. How many trials, how many buses are we looking at? 15. What's the probability of each bus? 0.15. Okay, we are looking for what is the probability that exactly 4 buses are late. And we get 0.1156. Let's double check that. What went wrong? 15.354. .1792. .354. Oh, God, you guys, I put 0.15. How many times am I going to get a wrong answer because I typed something in incorrectly? Please, 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 please learn from my mistakes. I normally just make another video, but videos take a long time, so we're just going to fix my mistake. You can do that by going up, hitting enter, and change my 0.15 to 35. But see how, always check your answers. Set 0.1792 or 17.92%, which matches our highlighted area here, okay? All right, let's see. The next one approximately 17.9%, is exactly 3 trains. So you can either type in the same exact thing we just did, 15.353, okay, into your calculator, which you can just arrow up on your calculator and change that 4 to 3. So approximately 11.1%. And we can check this calculator here, 3, boom, same. Okay, so I double check my answers. I know that that's correct. It's the highlighted pieces in this histogram. We're looking at the highlighted pieces of the histogram. Those are the buses that are going to be late. Okay. Right. What is the chance of at least, this is where it gets a little confusing. What is the chance that at least 10 trains will arrive on time? So at least 10 trains means 10 trains could be late, 11 trains could be late, 12 trains could be late, all the way up to 15. In our histogram, what this looks like is if we highlight, I wonder if I can just do this. If we highlight 10 through 15, and that adds it all together, right? It gives you the probability of 0.0124%. Or we type into our calculator. This is the hard part. Instead of using binomial PDF, you change it to binomial CDF, okay? And if we're looking for at least 10 trains arriving late, you have to put in a 9 here in the calculator. Okay, you have to put in a 9 in the calculator, but then we need to subtract that from 100%. So if we look at the histogram, if we look what's happening in the histogram, we put in 9 because, we put in 9 because that's going to give us the area to the left of the curve, right? Which would be all of these bars of the histogram that are not highlighted. But when you put a 9 into the calculator, that's the area it gives you. But we want the opposite part. We want the part on the right-hand side of this histogram. So we have to subtract it from 100%. Remember, the whole histogram or the whole distribution has to add up to be 100%. So into the calculator, let's do this. Into the calculator, what we are going to type in is 1 minus, then we're going to go back to distribution, which is second bars, arrow down to the CDF, which means combined, so you're adding things together. Binomial CDF, okay, still have 15 trials. God, let's type this in correctly. Still, each trial is a 35% chance of something being late. We want 9, right, because we want at least 10. Paste. Okay, and we get the same answer, 0.01244. And then on the website, it gives us 0.0124, right? So we've double checked. It's the area of everything I have highlighted added together. So what you could also do is see the things that are highlighted in purple. If you add those together, that gives you the 0.0124, the probability that all of those buses are going to be late. Okay. So 0.0124 is approximately 1.24%. Yeah. All right, so what is the chance at most 3 trains will arrive late? This time we want 0, 1, 2, or 3. So we want the left-hand side of that curve. So if you're using your TI, you would type in binomial CDF, 15 trials, 35% probability each trial, 3, okay? Or if you want at most 3, if you go back to your online calculator, you want to highlight 0, 1, 0, 1, 2, 3. There we go, 0, 1, 2, and 3. And we get approximately 17.27%. So all of that purple part of the curve is what it's adding together. Double check on your calculator. Make sure you can do it on the calculator and get the same answer. Okay, and then question 5, what is the chance of between 2 and 4 trains arriving late? So here, between 2, so we want 2, we want to add up 2, 3, and 4. 2, 3, and 4. You can also, instead of trying to highlight the table, if you look down, you can also change below where we put in our number of trials. The probability, I would put a 2 here. X is in between 2 and 4. It could be 2, it could also be 4. So X is greater than or equal to 2, X is less than or equal to 4. Probability is approximately 33.78%. So those highlighted pieces of the histogram add up to be that. In the calculator, it's a little bit trickier. You have to type it in as finding all of the probability, the binomial CDF, that 0, 1, 2, 3, or 4 buses will be late, and then subtracting the probability that 0 or 1 buses will be late will give you the same answer of, what was it, approximately 33. Okay, and then here's where it says cumulative, which is why we are using the CDF instead of the PDF, because we're adding all of those parts of the histogram together. Okay. All right, problem 2, suppose we know that the population proportion P of left-handed students is 0.10 and that we have a random sample of n equals 100 students. Find the mean or expected value. This is literally from the formulas we went over above. So mu, or the mean expected value, is n times P, is 100 times 0.10 is 10. And then calculating the variance was n times P times the complement of P. The complement of P would be 1 minus 0.10, which is 0.9. If you put that into the calculator, you get 9, right? Because we know n times P is 10, we just did that. And then we have 1 minus 0.1, and that will be equal to 9. And your standard deviation is the square root of that 9, okay? So the square root of 9 is just 3. You can use that online calculator we were talking about. Here our n is 100, our probability is 0.10. If we go back to that online calculator, we are changing our n to be 100 and our probability to be 0.1. My computer is being slow. I may need to restart it. Oh, I put in 1,000 for the n. Maybe it's not me, all of these mistakes. It's just my computer. Okay. I just refreshed this page. And our n is 100. Our p is 0.1. Okay, and then look up at the top here. Our mu, or our expected value, is 10, and our standard deviation is 3. Doesn't give you the variance, but if you square the standard deviation, that gives you the variance there. Okay. All right, please make sure you write down any questions. Please go back and pause the video to figure out how to use the calculator and write that information down, and ask me any questions in our next meeting.